Welcome to The Explainer. Today, we're diving into a topic that's quietly becoming the engine for the next wave of AI, synthetic data. It's this incredible solution to one of the biggest roadblocks in tech, and we're going to break down exactly how it works. So, let's get right into it. Let's start with a thought experiment. How can a self-driving car possibly learn to handle a super specific, dangerous situation, say a deer jumping out on a foggy night, if it's never actually seen that happen in the real world? Trying to collect real-world footage of every single potential accident, it's just impossible. And that's exactly where our story starts. Here's how we're going to break it down. First up, the data dilemma. Why real data isn't always the answer. Then we'll introduce its stunt double, which is synthetic data. We'll peek under the hood to see how it's made, explore the amazing possibilities it's unlocking, and finally, we'll get real about the hidden risks we have to keep an eye on. Okay, so let's dig into that core problem, the data dilemma. I mean, we are surrounded by data, right? So why can't we just use all of that real-world data for everything? Think about it. From healthcare, diagnosing diseases, to banks, spotting fraud, to the car you drive. Pretty much everything runs on data. It's what we use to train all these amazing AI models. But actually getting your hands on enough of the right kind of real-world data, well, that's a massive challenge. And here's why it's so hard. First off, privacy. You can't just use real patient or customer data. That's a huge legal and ethical minefield, with rules like HIPAA and GDPR. Second, it is incredibly expensive and slow. I mean, just imagine the cost of cars driving millions of miles just to collect data. On top of that, some events are just super rare. Think about financial fraud. It happens, but it's a tiny fraction of all transactions. How do you train an AI to spot something it barely ever sees? And finally, real data reflects the real world, warts and all. That includes our built-in historical biases, which can teach an AI to make some really unfair decisions. And all of that brings us to the solution. It's a concept I love to describe as a stunt double for our data. Okay, so what exactly is synthetic data? The key thing to understand is that it is 100% artificial. This isn't just real data with the names removed. It is brand new data created from scratch by an algorithm. The whole point is to make it statistically identical to a real data set, to capture all the patterns and relationships, but without a single shred of real personal information. The stunt double analogy is just perfect. You wouldn't put your A-list movie star, your precious, sensitive, real data in a dangerous car chase scene, right? Of course not. You hire a stunt double, synthetic data, that looks and acts just like the star. It can do all the risky work, like training and testing, while the original star stays safe and sound, far away from any danger. And when you put them side by side, the advantages just pop. Real data, high privacy risk. Synthetic, low risk. Real data is often limited or hard to find. Synthetic data? You can create as much as you want whenever you want it. It's cheaper, and this is huge. You can actually design it to fix and reduce the biases that exist in your real-world datasets. So this all sounds great, but how is this artificial data actually made? It might sound like magic, but it's actually a really clever process. Here's the basic recipe. First, you take a sample of your real data and you let an AI study it. It's not memorizing it, it's learning the underlying rules, the hidden patterns, all of the statistical relationships. From that, it builds what's called a generator. Then you just turn that generator on, and it starts creating brand new, totally artificial data points that follow all those rules it learned. And finally, you have a quality check. You compare the new stuff to the original, and you keep tweaking the generator until its output is basically indistinguishable from the real thing. Now, one of the coolest methods for this is called a generative adversarial network, or GAN. Just picture a high-stakes competition between two AIs. You have a forger AI that's trying its best to create perfectly realistic fake data. And then you have a detective AI whose only job is to spot the fakes. They go back and forth, round after round, with the forger getting better and better, until eventually the detective can't tell the difference anymore. And at that moment, you know you have some seriously high-quality synthetic data. All right, so we know what it is and how it's made. So what? What can we actually do with it? Well, this is where things get really exciting. The benefits here are huge. You can share data for research without worrying about privacy. You can slash costs and speed up development time. But for me, the absolute game changer is testing for those edge cases. You can create those one-in-a-million scenarios, that bizarre fraud pattern that's never been seen before, or that chaotic traffic situation. You can train your AI to handle it before it ever happens in the real world. That's incredibly powerful. And this isn't some futuristic idea. It's already being used all over the place. The biggest areas right now are healthcare, for training diagnostic AI without ever touching a patient's private records, the automotive industry for self-driving cars, and of course finance, for things like spotting fraud and managing risk. This quote from Nishant Arora at AWS really nails it. You can train an AI on synthetic medical scans without violating anyone's privacy. You can teach a robot how to handle objects in a simulation, instead of having it break expensive real-world prototypes over and over again. It's just safer, faster, and way more efficient. And the results really do speak for themselves. In banking, because fraud is so rare, AI models can struggle to get good at spotting it. But by using synthetic data to create way more examples of fraud for the AI to learn from, studies have shown you can boost accuracy by up to 35%. That's a massive improvement. But, and this is a big but, like any powerful technology, this is not some magic bullet. It is not a perfect solution, and we absolutely have to talk about the hidden risks. Okay, this is probably the most critical point to understand. There's this dangerous misconception that if data is synthetic, it's automatically 100% private and safe. That's simply not true. If it's not created very, very carefully, it can still leak information and pose serious risks. And that leads to one of the biggest long-term fears in the AI community, something called model collapse. Just imagine a future where the internet is flooded with AI-generated text and images. The next generation of AIs are trained on that data, not on real human-made content. Then those AIs create even more AI content. Each cycle is like a blurry photocopy of a photocopy, until the models get so distorted, they basically forget what reality even looked like in the first place. So here are the key risks we have to watch out for. Sometimes the AI generator can accidentally memorize and spit out bits of the real data it learned from, opening the door to privacy attacks. If you're not careful, it can also amplify the biases from the original data instead of fixing them. And then there's the huge challenge, especially for things like robotics and self-driving cars, called the sim-to-real gap. A model can be perfect in the simulation, but then fail spectacularly in the real world because the simulation just wasn't quite perfect enough. And it really all comes down to a tricky balancing act. A study from the University of Michigan puts it perfectly. The more useful and realistic you make the synthetic data, the closer it gets to the original real data, which can actually increase the privacy risks. So it's this constant trade-off between how useful the data is and how safe it is. So what's the big takeaway from all of this? Well, synthetic data marks a really fundamental shift in how we think about information. For decades, data was something we had to go out and collect from the world, like mining for gold. Now it's becoming something we can actually design, engineer, and build for a specific purpose. And that leaves us with a huge question for the future. We now have the ability to manufacture one of the world's most valuable resources. We can literally design our own versions of reality to train our machines. So the challenge isn't just about whether we can do it, it's whether we have the wisdom to design that data and the world it creates wisely. Thanks for watching.